Hi, hello everyone. This is RK. Welcome back to my channel Byte Code with RK. If you are new to my channel, please do like, share, and subscribe to my channel. In last session, we have discussed lambda expressions. I hope you all enjoyed the last session. If you have any queries, please comment below.
Let's recollect what is lambda expression. Lambda expression is an anonymous function or a short block of code, or we can call it as inline function, inline code. So generally, this lambda expression used to implement means it provides the implementation of the abstract method of the function interface. Then what is function interface? An interface having single abstract method is nothing but a function interface, and it can have any number of static or default methods. So to start the implementation of lambda expressions, we need a functional interface. So from the definition, we clearly understood that lambda expressions works with the function interface only. That's why we need a functional interface. So let's take one of the functional interface, means predefined functional interface. First of all, let me create a class. So here I am creating a class. So I am naming it as lambda example. So I have created a lambda ex example as the class name. So to create the lambda, we need a functional interface, right? In Java, we have multiple functional interfaces, predefined functional interfaces we can also write the custom functional interface also. For now, just since it is related to lambda expression, so we will make use of the predefined functional interfaces only. In this example, I am taking one of the existing or predefined functional interface, that is runnable is the functional interface. From the definition of what I said, functional interface, if I open the runnable interface, if you see here, so what is a functional interface? A functional interface is an interface which is having single abstract method. If you see, the runnable is an interface, and how it becomes functional interface, because it's having single abstract method. If you see here, run method is abstract method, abstract void runnable run method. So this is runnable becomes functional interface when it having single abstract method. So lambda ex is implemented by runnable interface. If you see here, since runnable having abstract method, right, so it will force the lambda expression to override that method. So that's why I am adding unimplemented methods. So lambda having run method we have seen, right? So when you class is implemented by interface, if the interface having abstract methods, so then the interface forces the implementation class to override all the abstract methods in it. So since runnable having run method, so it was forcing the implementation class to override the run method. So that's why I am overriding the run method here. Whatever you are seeing, right, this is all about before lambda expression. So why I am explaining before lambda expression means, if I explain this one, then only you will come to know like what is the purpose of lambda. Here I am just writing a statement only, overriding the run method with a statement, and the statement says before lambda means this is all about before lambda implemented by runnable interface. Now I have overridden run method, so I need to call this run method. I am creating a thread object and passing this lambda ex object to the thread class. And I am starting the thread 3.start. Now what will happen, thread T will internally refers to the lambda expression class, and it is implemented by runnable interface, it having run method. So it will override, it will directly when t1.stud is executed, then the overridden run method of the lambda ex, and it is implemented by runnable interface, will be executed. Let me execute this step. this program. If you see here, before lambda implemented by runnable, okay, the statement is executed. Before lambda, what we have to do, we need a runnable interface, and the class is implemented by runnable interface, and once it is implemented by runnable interface, it should override the methods of the runnable interface. So that's why I have overridden run method from the runnable interface, and it is implemented by lambda ex. So and then I have created the a reference for the lambda ex, means I have created an object of it, and then I pass this object to the thread class, so to execute this one, because once t dot start calls, it will directly call the run method of the runnable interface. Okay, so this is like before lambda, and you should do all these things before lambda. Now let's see the same implementation with the lambda expressions. Okay, creating a reference of runnable are equal to lambda expressions are represented by like parenthesis followed by arrow mark and then curly braces. We have discussed it right in the last session, ways to represent a lambda expression. In the parenthesis you can pass the parameters, or it can be empty. In the statements you can write couple of statements or logic, whatever for your requirement you can write. If lambda expressions are, why they have called short block of code, because it was reducing the length of the code. It means I am writing inline code. Generally if you implement runnable, right, it was forcing the lambda expression to override this method. Okay, you are overriding the run method of the runnable interface. But what I am doing with the lambda expression, I am just writing the block of code. This is nothing but a block of code only, right? I am writing the code within this curly braces. It's like a block of code. It doesn't have any name, right? If you see here, it doesn't have any name. It just showing the parameters empty and then curly braces. Okay, so it doesn't have any name, because lambda expression is anonymous function. Anonymous function means a function without name is called anonymous function, or lambda expression is a short block of code. It is a block, right? It is a block. Anything written within the curly braces can be called as a block. So it is a block of code, and also you can call it as a lambda expressions or inline code. So here only I am writing. Now I am writing the code. Here only I am writing the code. Wherever I required, there only I am writing the code. Okay, implementation of the run method I am writing. So how this syntax comes into the picture means, if you see here, runnable is an interface. It is directly referring the run method. Earlier we have overridden run method, right? With the lambda expressions, overriding is avoided. So maybe you will easily understand after seeing that one. I have a run method. What lambda expressions will do means, it will avoid this public void run method. Writing this is optional with the lambda expressions. Now you see way of lambda expressions. This is the way of lambda expressions, right? So you are writing parenthesis, and run method also having parenthesis. Public void run is I am removing. Now it becomes almost similar to the lambda way of representing, right? If you see here, I have parenthesis, here also I have parenthesis, and I have followed by arrow mark and then curly statements, curly braces. Here also I am just adding arrow mark in between the parentheses and curly braces. So this is like shortening the code, right? So that's why we call it as a short block of code, or inline code, or anonymous function. Short block of code means I am reducing the public static void main also, and inline code means I am writing the code here only instead of overriding in run method. Okay, short block of code, and I'm calling it as anonymous function means it doesn't have any function name. It's without function name, it just having the body. I'm writing statement inside it. After lambda. So I'm reviewing this one. Okay, now the length of the code is reduced, and I have written inline statements only, and it is a anonymous function. I hope from the definition you are clear about what is lambda. So let me comment this one also, so that now I am not calling this one. Now let me create a thread. T1 equal to thread of. I am passing that runnable reference to the thread class, and T1 dot start. Okay, now it is not throwing any error. I will comment the start method also, because start method anyway I will comment all these things. Okay, and for lambda expressions, right, you no need to implement the runnable method, so I am commenting this one also. Now it is not throwing, even I removed the implementation of runnable method, it is not throwing any error. And I stopped overriding the run method, because I am not implementing runnable interface. Right here I have commented runnable interface, so when I commented overriding run method is not required. Let me run this program. See, if you see here, it is called after lambda. I hope everyone cleared about the lambda expressions. At least you will get like what is lambda, and how we will implement the lambda, and what is the way of representing lambda expressions, and how the code is reduced in lambda, in writing lambda expressions. This is like a simplest way of representing lambda expressions. So far we have seen way of representing lambda expression with empty parentheses. Let me see one more example with parameters. This is like empty or without parameters. Let me see one more with example 2. So I'm doing example 2. So I'm taking one more functional predefined functional interface to explain this example. It is like consumer. Consumer is a functional interface. Let's open the consumer class. If you see here, a consumer, why we call it as a functional interface means it is having single abstract method. Accept method is the abstract method by default. If you see here, it's having only one abstract method, accept method, and it can have default methods or static methods. So default here we have default method only. We don't have any static methods for this interface. We will see static methods also in upcoming sessions. For now, just remember we are using consumer interface. Consumer C equal to, right, so there are multiple ways of representing. Now I am writing the implementation for the accept method. Okay, so accept method accepting over single parameter, so I am writing parameter as S. Okay, and followed by arrow mark and then curly braces. If you see here, I am writing statement inside it. From consumer, so I'm here. If you see here, within the parentheses I am taking single parameter and followed by arrow mark and then curly braces. Within that curly braces we have written some statement. Okay, so now I am calling C dot accept of to. Okay, so the consumer interface having single abstract with that abstract method we are passing the some value. So here it will comes to when you add this statement, right, C dot accept of, you are passing string as a parameter. So if you come to here, it was taking S as a string and then printing the same here. Let me run this one. Let me run this one. So if you see here, it was calling. This is the about the first statement with the first example. The second one is from the consumer. So we have written right from consumer, and we are passing welcome to bytecode in the accept method. Here we are providing implementation for the accept method. It was representing in lambda style. So it was accepting single parameter. I am taking single parameter within the parenthesis followed by error mark, and then a statement is just to print the whatever we are passing in the accept method. So like this is all about the lambda expressions. So I hope this is clear for all of you.
I hope you will learn something from this session. If you have any queries, please comment below. Looking for more videos, please click on the bell icon so that you will get notified. See you in the next session with the new topic. Thank you.